Hi and welcome to MSc. In this video we're going to be looking at naming ionic compounds that contain polyatomic ions. Now a polyatomic ion is a group of atoms that act together as a single ion. They're bonded together, they are a group, they typically move around through a chemical reaction altogether, although occasionally they have to form or break apart, but they have their own charge. There are lots and lots of polyatomic ions. Here are 5 of them that we'll work with and look at in this video, but there are many. Now, some teachers will give you a chart that you can use as a reference tool to know the name and the chemical formula of the ion as well as the charge. Other teachers might ask you to memorize some or quite a few polyatomic ions. Certainly, if you want to move ahead in chemistry, there are a bunch that you should just know because you use them quite a bit. One of the key parts of the polyatomic ions is the different endings, the different suffixes that you'll see. We'll see some of the "ide" ending that we're used to already from ionic naming, but we'll see "ate" endings, you'll see "ite" endings, and you even have other endings like an ammonium here. Now there's different naming conventions that can be used for polyatomic ions depending on how far you take it into chemistry. You can have names like nitrate and nitrite, and so you have to be careful when you're reading them that you pick up the right ending because that refers to a different number of oxygens that are there. You might also, in your chart, if it's a big chart, also have things like hypo as a prefix that goes in before, like hyponitrite or pernitrate. Those are part of a bit of an older convention that's still widely used. Again, as you're memorizing, refer to what your teachers told you in terms of the naming. There's other naming that looks at the actual charge on the non-oxygen atom, for example, as well, called an oxidation state. I'll go through with this naming for this video. The other thing you'll want to take note of is the charge. This has a -2 charge, and that means this whole polyatomic ion, this group of 1 carbon and 3 oxygens, all has a -2 charge. So it's pulled electrons from somewhere else to form this ion. And you can see these have -1 charges, and this has a +1. Most polyatomics will be anions with the negative charge, but we do have some that are cations as well. The good thing is that the crisscross method that you've learned in the past for finding ionic compound formulas still works with polyatomics. Don't forget to use your chart, refer to it, and then don't forget to reduce subscripts whenever you need to. So let's look at a couple examples. Sodium is Na, and I know that it forms a plus ion because it's in the first column in the periodic table. Hydroxide, we can look up in our polyatomic chart and find it's OH negative. That means it has a -1 charge. Now we can do the crisscross. There's a 1 here that we don't write that can cross down here. And there's a 1 here that we typically don't write that'll cross over here. That leads us to a formula that's Na1OH1. So NaOH is sodium hydroxide. Okay, second example here we have manganese 4. Well, that tells me that we have Mn4+, it's a transition metal, and carbonate. And the carbonate I can look up in my chart, it's CO3, 2 negative. There's a couple things I want us to note as we work through the rest of this example. We'll do the crisscross as normal. A 4 comes over here, and a 2 comes over here, and then we can write it out and say it's Mn2 CO3 4. But we can't have 3 and 4 back. It looks like 34. It looks weird. What we do here is we put the CO3, we put the polyatomic in brackets, and that tells me that I have 4 of the CO3s. But in this case, you might also notice that 2 and 4 can be reduced if we divide by 2. Take special care with this to never reduce the actual subscript on the oxygen or anything in the polyatomic itself. Only what goes outside a bracket is what can be reduced. So we can write this final as Mn, 1 that I won't write, bracket CO3 bracket 2. We don't want to distribute this 2 inside, even though in fact we do have 2 carbons and 3 times 2, 6 oxygens. We don't want to write it as MnC2O6. If we do that, we lose some of the structural information that's hidden here in this formula. This tells me that I have 2 carbonate ions, those groupings of CO3s, bonded around the manganese. So a lot of information is hidden in that formula. Naming ionic compounds with polyatomic ions is just like naming that we've already done for ionic compounds. We're going to watch for the suffix, that's the end, the ATE or the ITE or the IDE ending. And we're going to use our polyatomic chart as a reference. If you're trying to memorize them, use it as much as you can to help you memorize. And then we're still going to apply the zero-sum rule if it applies. So here I have LiNO3. So I recognize that we have a polyatomic ion here with the NO3. And we have lithium. So we can write lithium. And lithium is not a transition metal. It is in group 1. So I don't need to worry about the zero-sum rule. I just now need to identify my polyatomic. And my polyatomic is nitrate. So this will be lithium nitrate. In the second example, we have lead. Well, lead is a transition metal. So this will be lead something in brackets. And then the polyatomic that we have to acknowledge is here. It's NO2, and there's 2 of them. So I use the NO2 part to help me name it. It's not nitrate, it's nitrite. And again, you have to be very careful with the names of these because you can tell that there are some similarities between different compounds or different polyatomics. So now we need to figure out the charge on this lead ion that's part of this compound. So we'll use the zero-sum rule. And that tells me that the whole charge on the whole particle here is 0. So I have 1 lead atom because there's a subscript of 1 that we don't write. I don't know the charge. Plus there's 2 of the nitrites. And the nitrites actually have the same charge as the nitrate as at -1. This is all equal to 0. 1 times x is x. 2 times -1 is -2 equals 0. And so x is equal to 2, which tells me it's lead 2 nitrite. I hope this quick run through of polyatomic ions and how they work in ionic compounds has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you very much for listening and watching.